you might want to remind yourself about drawing dashed or solid lines. Remember, if it doesn't have an equal sign underneath it, it's dashed. If it does, it's solid. Rules for shading diagonal lines. If it's less than or equal to, you're going to shade below. If it's greater than or equal to, you're going to shade above. Then what's new today is horizontal and vertical shading. So if it's a vertical line, that means it's going to go through the x-axis. You're going to shade right or left. And if it's a horizontal line, it's going to go through the y-axis, and you're going to either shade above or below. So let's take a look at problem number 1. It's already done for you, where it is y is greater than 2. So before, you were used to graphing a line that said y is equal to 2. So remember, it must go through the y-axis. So this is our y-axis, and right down here is our x-axis. And any values that are greater than 2 would be above the 2 on the y-axis. Now another thing is, too, it's going to be a dashed line, not a solid line. Let's take a look at problem 2. First of all, let's move our variable to the left, and then let's flip the symbol, less than or equal to 20. So it is going to be a solid line. So I'm not for sure what happened right here, but that should be definitely be a solid line. And any x values that are less than 20 is going to be shaded to the left. All right, let's practice shading down here. So on number 3, we have y is less than x. So remember, our y-intercept would be 0. It does go through the origin. So where would y values, again, this is our y-axis and this is our x-axis, be less than the y-intercept of 0? Would be down here where the negatives are. So that commits you to that side of the line. So it's going to be everything below. Number 4, this is x is greater than 2. So remember, before we have graded x is equal to 2. So it goes down through the x-axis. And since it doesn't have an equal sign, it's going to be a dashed line. So then you ask yourself, where are the x's greater than 2? So again, if this is your x-axis, they would be over here at 3, 4, 5, and so forth. So that commits you to that side of your dashed line. Number 5, y is less than or equal to 3, so it's going to go through the y-axis at 3, and it is going to be a solid line because it has an equal sign. So where would y values be less than 3? Well, they're down here, 2, 1, 0, and so forth. So that commits you to that side of the line, so it'd be everything below that line. Let's look at the back page. Here it says solve for y. So we're going to solve for y. So that's one reason why we were practicing that on the previous notes, on notes 32, so that we could solve for y, and then we're going to graph it. So on problem 6 here, we're going to move the 2x over to the other side, bring 3y is greater than, 2x becomes a negative 2x plus 6. And then we're going to divide everything by 3. So y is going to stay greater than 2/3 x, and 6 divided by 3 is 2. So the line should be dashed because it doesn't have an equal sign, and it's greater than, so we're going to shade above the line. So we're going to begin at 2 on the y-axis and go down 2, right 3, go down 2, right 3. And then this will be a dashed line. And then we're going to shade everything above. Because we ask ourselves, where are y values greater than the y-intercept of 2? And they're above that line. Now then, I want us to go down below. And it says, are the points a solution to the given inequality? So we're going to put a Y for yes or an N for no. Show work, then verify on the graph. So what we do if we don't have a graph is you would put a 4 in place of X and a 2 in place of Y. So it'd be 2 times 4. Sorry, I wanted to put 8 in there. Plus 3 times 2. And see if it's going to be greater than 6. So 2 times 4 is 8. Plus 3 times 2 is 6. So that's 14. Is 14 greater than 6? Yes, it is. So the ordered pair 4, 2, if you look up in the graph, if you start at 0 and go right 4 up 2, it is in the shaded region. So therefore, the point 4, 2 is a solution. It is in the shaded area, so it is a solution. All right, so we're going to use the same equation, and we're going to put a 0 in place of x and a 2 in place of y and see if that is greater than 6. So 2 times 0 is 0. 0 plus 3 times 2 is 6. So 0 plus 6. Is 6 greater than 6? No, it's equal to, but there's not an equal sign. So if you look at the order pair 0, 2, now this is where it gets to be a little bit tricky. 0, 2 is on the dash line. It is not considered a solution because it's on the dash line. If that line were solid, then it would be considered a solution. All right, let's go try another one. All right, so on number 7, let's try a different color. All right, so we're going to take that x, we're going to move it over to the other side, bring down negative y is greater than or equal to negative x plus 4. Now that negative y is understood to be a negative 1y. That looks like a 7. That's a negative 1. So we're going to go through and divide everything by a negative 1. When you divide by a negative, you're going to flip the inequality symbol. And then a negative 1 divided by a negative 1 is a positive 1x. And 4 divided by negative 1 is negative 4. So this is going to be a solid line, and it's less, so we're going to shade below. So we start at negative 4 down here, and then just continue to go up 1 over 1. Put our arrows, and we're going to shade below because we're going to ask ourselves, where are y values less than the y-intercept of negative 4? Well, they would be down here. So that commits you to that side of the line. All right, so now let's go down and see what points they're asking us to look for to see if it's a solution. So the order pair 0, negative 2. So algebraically, we would put a 0 in place of x minus the y is a negative 2. So 0 minus a negative 2 is a positive 2. And we're going to see if that is greater than or equal to 4. So is 2 greater than or equal to 4? No, it's not. And if you look at the order pair 0, negative 2 is right there. That is not in the shaded area. Let's use the same equation here. So we're going to put 2 in place of x minus our y is a negative 2. So 2 minus negative 2 is 4, is greater than or equal to 4. Is 2 plus 2, which is 4, is that greater than or equal to 4? Yes, it's equal to. So it'd be yes. If we look at the order pair 2, negative 2, so start at 0, we go right 2 down 2. It is on that line, but this time, unlike problem 6, the line is solid. So if it's solid, then it's going to be considered a solution. All right, let's go ahead and take a look at number 8. This one is x is less than negative 1. So if it's x, it's going to go through the x-axis. This is your x-axis. So it is going to be dash because it doesn't have an equal sign. So let's go ahead and get that drawn, and then I'll let you see what we're talking about here. So less than, so this is going to be a dashed line, less than negative 1. Now, this is what we're talking about, left or right. So where would x values, remember we're looking on the x-axis here, be less than negative 1? What would be to the left? 0, negative 1, negative 2. Let's go back. I just realized that I drew it at positive 1 instead of negative 1. Sorry about that. So we're at -1, and it's going to be a dashed line. Okay, and where are x values less than -1, they will go to the left, -2, -3, and so forth. So we're going to shade this. All right, so let's go down below and see what order pairs they want us to look at. So if -3, we're not even going to use the y value because we don't have any y's in it. So we won't even use the x there. So is -3 less than -1? Yes, it is. So let's go down here and take a look at -3, -1. So if we go left 3, down 1, it is in the shaded area. And then -1, 0. So we're going to put a -1. Again, we will not use the y. Is -1 less than -1? No, it's equal to. So -1, -1 would not be a solution. And let's take a look at the graph. If we go left 1, down 1, it falls on the dashed line. So remember, when it falls on the dashed line, it is not considered a solution.